The 5Es Instructional Model and Universal Design for Learning. Jessica Jones, Instructional Models for Digital Learning, March 18, 2016, American College of Education. In the book Science Education Leadership, edited by Jack Roten, it states, using the BSCS 5E instructional model, or another variation on the learning cycle, provides connections among curriculum, instruction, and assessment, and enhances students' opportunities to attain learning outcomes, including 21st century skills. Within this presentation, you will find 3 parts surrounding the use of the 5Es instructional model and universal design for learning. In one part, you will find a review of the 5Es instructional model. Part 2 includes discussion on the application of universal design for learning through the 5Es model. Finally, Part 3 provides a description of a 6th grade science lesson using the 5Es instructional model. The 5Es instructional model consists of 5 phases: engage, explore, explain, elaborate, and evaluate. In the first phase, engage, the teacher provides activities to capture students' interest and help them make connections with what they know and can do. The teacher can also use this as an opportunity to pre-assess student understanding of the concepts addressed in the lesson. In the second phase, explore, the teacher provides minimal explanation or instruction, and the students are given the opportunity to create a common set of experiences. Explain, the third phase, allows the teacher to provide instruction on the content and students to communicate their misconceptions and understanding. The fourth phase, elaborate, allows students to deepen their understanding and apply their knowledge to unique and/or real-world situations. Finally, evaluate, the fifth phase, renders students with an opportunity to participate in self-assessment. The teacher will also use more formal forms of assessment, such as written exams, performance tasks, or project-based learning formats, to determine how much understanding has taken place. Universal Design for Learning, or UDL, consists of 3 brain networks and 3 guiding principles. The recognition network provides multiple means of representation. This brain network provides options for comprehension, language, mathematical expressions, symbols, and perception with a goal of creating resourceful, knowledgeable learners. Educators look for methods to present information and content in different ways. This UDL principle can be found in the second and third phases of the 5Es instructional model. Another UDL brain network is the strategic network and provides multiple means of action and expression. In this network, students are given opportunities to practice executive functions, such as goal setting and choice as to how they will express and communicate their learning. This UDL principle can be found in the third, fourth, and fifth phases of the 5Es instructional model. Finally, you have the affective brain network, providing multiple means of engagement. Students become purposeful, motivated learners as educators stimulate interest and motivation for learning. Opportunities for self-regulation and persistence are also given. This UDL principle can be found in all phases of the 5Es instructional model. In the following slides, you will be provided with an example of how the UDL principles can be applied through the 5Es instructional model. The lesson I will use to show you how the principles of UDL can be applied in the 5Es instructional model is from a UCLA teacher-initiated inquiry project sample. The lesson is for 6th grade science students on the topic of density. The TIP project is focused on implementing the Common Core State Standards and Next Generation Science Standards. In this lesson, 6th grade students will learn about the science topic density and the physical characteristics of solids, liquids, and gases to design a solution that solves a practical problem. To pique student interest and provide the educator with a pre-assessment of student understanding, students will participate in a sink or float activity. In this activity, groups of students are given a list of objects to determine if the objects will sink or float. After each group has the opportunity to observe the object's physical characteristics, they will make predictions as to whether each object will sink or float. Once the predictions are made, each group will test their hypotheses by placing each object in a small tub of water. Finally, the teacher will inform students how the properties of each object determine their density. The UDL principle of engagement can be found in this portion of the lesson. Students are motivated to ask more questions and seek answers as each object is observed and eventually tested. For example, the paper clip sunk, so will the can of soda sink. Students will complete the ice cubes activity to build their own set of experiences and understandings about the properties of liquids, solids, and gases in the explore phase. Each group is given 2 different liquids containing ice cubes. Next, students are asked to use all their senses, except taste, to observe the ice cube in each sample. Finally, students are asked to record and illustrate or draw what they believe is happening in each sample. Student engagement is further heightened through the continued provision of interest, but also through optimizing challenge. The UDL principle of representation is also included in this phase due to the option for student comprehension to begin. Through this portion of the lesson, students are becoming motivated to learn the material, and therefore, they are beginning to seek understanding and comprehension. For the explain phase, the educator will now provide scientific explanation and content instruction on the topic of study. First, the teacher will explain density, buoyancy, and how they are related. Next, the students will watch a video clip on density and buoyancy before beginning their project. To demonstrate comprehension, the students will determine their own definitions of the terms and provide real-world examples. These products will be shared with the class. The UDL principles of action and expression and representation are provided in this phase of the lesson because students are provided options for expression and communication, information is presented in different ways, and students are allowed to activate prior knowledge to enhance comprehension. In the 4th phase, elaborate, students will participate in the foil boat activity. Here, the students will elaborate on their understanding of the concept and apply the concept to unique, real-world scenarios. With a partner, students will be assigned the task of creating a boat made of tinfoil. The goal is to design the boat that will float holding the most pennies. Students will follow the scientific method in completing the experiment, where they will question, hypothesize, conduct an experiment, analyze the results, and make a conclusion. Through the use of the scientific method, students may be able to modify their boats to produce a more suitable product. Students are given options for autonomy and relevance, options to foster collaboration and community, opportunities for goal setting, and tools for construction and composition. This provides evidence of the implementation of the UDL principles engagement and action and expression. Finally, in the evaluate phase of the lesson, students will participate in a self-assessment and formal assessment. The self-assessment consists of the student compiling a video photo journal. The journal should include all the key terms and ideas from the lesson with corresponding video or photo of real-world examples. For the formal assessment, students will have the choice to take a written exam, give a presentation, or complete a demonstration. The presentation would be similar to the video photo journal. However, the task will require students to use a presentation tool to display their understanding in a fluid manner. The demonstration could require students to design and build a hot air balloon, or another task involving the topics of density, buoyancy, and/or physical properties of objects. The UDL principles of engagement and action and expression are once again evident in this portion of the lesson. Students are provided with options for sustaining effort and persistence, self-regulation, expression and communication, and executive functions, such as planning. Within this presentation, I discussed the 5 E's instructional model and how universal design for learning can be applied. There was also application of the learning models through a UCLA tip lesson on density. From the experience, I recognize the importance of utilizing UDL and instructional models, such as the 5 E's, to engage students in authentic, real-world learning that will serve them well in today's 21st century environment.